So today we're just going to be doing numbers 5. We're skipping 7 and 8 for today. We're going to do it tomorrow. And then we're going to do 9 through 15. So we're doing this one, 11, 13, and 15. That's a total of 5 questions today. Okay. So there's one compound inequality, and there's the rest that are absolute value inequalities. So should we start working on this together? So number 5, what's the first step to start solving this compound inequality? Adding 20 is correct. Plus 20, plus 20, plus 20. Remember, what you do to the middle, you do to both outside sides. Okay, so negative 8 plus 20, that is 12. And what do we have left in the middle? We have the 3y. Bring down that inequality. We didn't divide by a negative, it stays the same. This one also stays the same. And over here, 52 plus 20 is 72. All right, so for the next step, divide by 3 is correct. So we're going to divide by 3, and what you do to the middle, you do to both outside sides. We will have a 4 is less than or equal to a y, which is less than, and 72 divided by 3. So that's our answer. What do we know about this number line when we graph it? What do we know about the areas? Well, first of all, open dot or solid dot at 4? Here's 4. There's a solid line underneath it, so you're going to do a solid dot at 4. Let's go over here and put a solid dot at 4. And what was the other answer? 24? Yeah. Was it an open dot or a solid dot at 24? Open. It doesn't have a solid line underneath, so let's put an open dot at 24. Now, are these areas going to be together or apart? Together. And we don't even have to think about the inequalities. They're going to be together because the whole thing is written together as a compound inequality to start with. So these areas are together. And if you look at the backside on the answers, it does have that graph right there. Okay, so we're skipping 7 and 8. If you happen to have already done them, that's okay. It's just the graph will be confusing. We'll explain the graphs tomorrow in 7 and 8. But let's jump to some absolute value inequalities. So number 9, it already has it isolated. So what do we need? Positive situation, negative situation. So the positive situation is 2w is greater than or equal to 5. The negative situation is the same thing, 2w, but what's different? It's a negative 5, but it's also a less than or equal to, right? So the inequality flips and the sign on the right side changes. And let's solve both of them. Well, you divide by 2, you get w is greater than or equal to 5 halves. And over here, divide by 2, w is less than or equal to negative 5 halves. Now, on a number line, 5 halves might not make that much sense. So let's change them to decimals. What's 5 divided by 2? What's half of $5? 250, right? So 2.5. So w is greater than or equal to 2.5. And w is less than or equal to negative 2.5. Now, the question is, do I need to write these with the word or between them? Or do I need to write these together as an actual compound inequality with w in the middle? The only way to determine that is to graph it. So the greater than or equal to 2.5, go to 2.5. It's going to be a solid dot at 2.5. So let's put a solid dot right there. And greater than or equal to, greater than is to the right. And the other one, w is less than or equal to negative 2.5. Go to negative 2.5 and put a solid dot right there. And less than is to the left. So these are definitely apart. So my final answer should remain apart with the word or between it. So you could go back to here and simply put the word or right between both of those, and that would be your final answer. W is greater than or equal to 2.5, or W is less than or equal to negative 2.5. But you do need the word or between them because the areas are apart. And if you check in the back, it states it with the word or between it, and it does have that graph pointing apart from each other. Number 11. Let's do positive and negative situation. The positive situation is writing it exactly the way it is without the absolute values. There it is. The negative situation is the same exact thing, but we have to flip the inequality symbol and change that sign of a positive 3 to become a negative 3. And we're going to solve both of them. Plus 8 plus 8, x is greater than or equal to 11. The other one, plus 8 plus 8, x is less than or equal to 5. So I don't know if I write these together or if I keep them apart with the word or. So in order to determine that, we have to go to the number line. So it's solid dot on both 5 and 11. That didn't work out that great. There is no 5 or 11. So a solid dot at 5, that'd be between the 4 and the 6, and a solid dot at 11. Now let's look at each one of these. What does that say? X is what compared to 11? X is greater than or equal to 11. So greater than, is it to the left or to the right? To the right, and we're on 11, so to the right. Now the other one, x is less than or equal to 5, is that to the left or to the right? Left, because it says less than. Less than is to the left. So let's go to that 5 and go to the left. So what do I know about my answer? Should it be together? No, it should be apart with the word or. So rewrite my answer right here on the side. It'd be x is greater than or equal to 11, or x is less than or equal to 5. That's my final answer, and my graph is right there. Let's check out number 13. Number 13 is the only one that we actually have to do step 1 of isolating the absolute value. So if we go plus 7, we now have absolute value of 2x plus 2 is less than or equal to 2. And then from there, we do the positive and the negative situation. And the positive situation is writing it exactly the way it is without the absolute values. And the negative situation is writing it exactly the way it is, but changing the absolute value, flipping it, and also changing the sign of the right side. And if you solve both, negative 2, you'll get 2x is less than or equal to 0, which means x is less than or equal to 0. Now the other one, minus 2, you'd get 2x is greater than or equal to negative 4, which means that x is greater than or equal to negative 2 if you divide by 2 on both sides. I ran out of space, I apologize. So let's graph both of those, see if they're together or apart. So it'd be a solid dot at 0. It'd be a solid dot at negative 2. Maybe I should do that one in blue since I wrote it in blue. And when we look at this one, it says x is greater than negative 2. Greater than's to the right. So I'd be going that way. And the other one is x is less than or equal to 0. Less than's to the left from 0. So here's your area enclosed with 2 solid dots. So since the area is enclosed, I actually have to write both of these together as a compound inequality. It's really easy to do. Put the x in the middle. Put the negative 2 on the left side, the 0 on the right side. What symbols belong right there? Less than or equal to symbols. It's always going to be less than, but if you have solid dots, obviously or equal to on both of them. If they're open dots, it's just less than symbols. Last question on today's homework. On this last question, you could actually just look at it, and it's the absolute value being less than or equal to a negative number. So that's an impossibility. There's no way that an absolute value could be negative 3 or negative 4 or negative 1,000. There's no way an absolute value could be any negative number. So you don't have to do any work right there. You just say no solution.